Every second, millions of sensory data points flood in, demanding to be parsed. Any complex system trying to process the sheer chaos of reality faces a massive risk of overloading. For the human brain, the greatest threat isn't the complexity of the data itself, it's a strict, unforgiving limit on metabolic fuel. Look at this diagram comparing mass to energy consumption. The brain accounts for a tiny 2% of our total body weight, yet it burns through roughly 20% of our daily energy. If we tried to analyze every single variable of our environment consciously, interpreting reality line by line, we would exhaust our energy reserves in minutes. Digital systems face an identical wall, struggling against the hard limits of hardware and electrical compute. When a programmer writes out raw, repetitive code to process datasets manually, the script quickly becomes a bloated, unmaintainable mess that drains system memory. Whether it's a biological neural network or a Python script, processing every variable from scratch guarantees a crash. To survive, the system has to become the ultimate code optimizer, and it has to stop repeating itself. Inside a modern programming environment, developers have a specific defense mechanism against resource depletion. It's the golden rule of computer science, DRY. Don't repeat yourself. Instead of copying and pasting the same block of logic, a developer wraps that repetitive code into a single function, writing the instructions once. Stored in memory, the system just calls the function to run quietly in the background. It is an elegant solution, saving computational power and keeping scripts beautifully lean. Long before the first line of code was ever typed, human evolutionary biology invented this exact same principle. In psychology, the biological equivalent of a Python function is known as a cognitive heuristic. These are mental shortcuts, rules of thumb that allow the brain to make rapid decisions without consciously analyzing every piece of incoming data. Think about learning to drive a car for the first time. Your cognitive load is entirely maxed out. You are manually calculating the mirrors, the pressure on the pedals, the tension of the steering wheel, and the erratic traffic around you. Fast forward a year, and you can commute all the way to work without actually remembering the trip. The mechanics of driving haven't changed, but your brain took all those repetitive actions and wrapped them into a mental function called drive to work. By running these programs in the background, the brain optimizes our interaction with reality, freeing up our conscious energy to focus on new problems. But there is a precarious downside to relying on background automation. In software, if you write a Python function using flawed logic, every single time you call it, you reproduce that bug across your entire application. The exact same danger exists in human psychology when we execute a flawed mental shortcut on the wrong set of inputs. When our internal logic is applied too broadly or to flawed data, the resulting output is a cognitive bias. Common shortcuts like stereotyping or the halo effect are these same energy-saving functions at work, applied to social data instead of survival cues. The brain prioritizes this speed over objective accuracy, sacrificing nuance to ensure the system doesn't starve its own reserves. Computer scientists manage this decay through a practice called refactoring, regularly sitting down to audit and rewrite legacy code so it stays accurate. While we rely on cognitive heuristics to prevent biological burnout, we have to continually audit our own minds. We must refactor our mental shortcuts to ensure our energy-saving logic isn't quietly generating a biased reality.